welcome back to this segment, continuation of the double angle formulae, okay, which were a review of the double angle formulae, which we want to use in the integrating of even powers of sine and cos. So in the first part, we came up with the expression for the sine, okay, of a plus b, which is sine a cos b plus cos a sine b. In this next part, we would like now to have the expression for cos of a plus b and see what we come up with. So, yeah, we are going to follow again a series of other substitutions here. So, by here, we are going to consider, if we look at the triangle RPU, okay, RPU, if we can go up here and look at the triangle RPU, I would like us to see that the cosine of angle A plus B equals to the adjacent, which is the adjacent side here, which is PU, okay, and then the hypotenuse, which is what? PR, okay. But remember that PR is the diagonal of unit length, so it is equal to 1. So we know here that cos A plus B is equal to PU, which is the adjacent of PR, but PR is of unit length 1. Therefore, we can say that PU in this case is equal to cos A plus B. That means that now we are going to look at the expression. We are going to look for the expression of PU. What is PU equal to? Okay. So PU, maybe we can get it here. We are going to get this length here, PU, as a sum of PV and negative PV and negative oh, just a minute, yes, PV and PV and negative UV, but we realize that UV is the same as QT, okay. So okay, let me just write it here, as we can see both the screen and both the result and the diagram here. So we are looking for PU. So PU, P to U, of course someone else would say that, hey, PU is just here, PU, just get it, PU. Yeah, it is right, but then we want, derive what we are trying to, derive. So we shall write PU, we shall go the really long way and write PU, P to U, as the sum of PV, P to V, plus negative VU. It's from here to here, then back, okay? So we can write this in short form and simply say minus UV. However, UV again won't be of any help. I'm talking this, of course, with hindsight, okay? Because I looked at the formula and I know where we are going to. So we won't be able to use UV. However, we know that the distance U to V is the same distance T to Q. So we shall just say QT. So luckily enough, in our derivations, we somewhere have a distance QT here. Okay, this is in the first part why I was wondering why we have it, because it seemed to be hanging somewhere. So we have TQ, okay, which we already have. We shall substitute it here, but perhaps we shall have to know RQ. Oh, we already actually the whole result is here. TQ is here, which we already have here. Okay, so this is done. So we are going to look at PV. Okay, so we simply look for PV. Okay, so we come here and then now I write that which we have there. We have said that PU is going to be the sum of PV and negative QT. Okay, so we already have PU here, which we got from here. QT, we already have it also from the previous, and so what we are simply interested in finding is PV. So PV, likely enough, we can get it from if we look at the triangle PQV. So if we look at the triangle PQV, okay, we can see that the cos of this angle B here is going to be equal to the adjacent side, which is PV divided by PQ, which is the hypotenuse. Okay, so we can say that cos B, okay, if I am really fast, when you're watching this, you can always just pause and try to take in, concept by concept. So if we make PV the subject here, okay, PV is going to be equal to PQ times cos B. Okay, and do we have a result for PQ? Let me see. Do we have a result for PQ? We surely must have a result for PQ somewhere. Let's try to look into our previous results here, and then we see if we have PQ. Okay, yeah, PQ is here, and PQ is cos A. Okay, PQ is there, which is cos A. So we simply say this is going to be equal to cos A cos B. Then I guess we have everything we need. Okay, if we haven't made a mistake here. So PV, what is PV? Okay, this one here. So we say it is cos A cos B, and then QT is the same as TQ here, which is sine A sine B. So we have this is sine A sine B, and then what is PU? We have PU here as cos A plus B. Yep. So we have come up with another result here, which I will highlight as well. Okay, so this other result here. Okay, yeah, so you have that cos A plus B is cos A cos B minus sine A sine B, and then we had here sine A plus B is sine A cos B plus cos A sine B. Okay, if I haven't made an error, I hope that is it. So yeah, but we are quite a long way from getting what we want here. So if we want to find the formula for tan A plus or minus B, it is quite easy to follow. We shall just do one and then you can complete the rest. So if we want tan A plus or minus B, we know that it is simply going to be sine A plus or minus B divided by cos A plus or minus B. So we shall just do maybe the first one of tan A plus B, and then you follow similar arguments to get the one of cos A plus B. Oh, to get the one of minus. Okay. Oh, okay. But we haven't yet looked, we did not look at what happens when we have a negative, or what happens when we have a negative. Well, the process is more or less the same. It's just that now, instead of having this triangle here, the rectangle here tilted such that we have an angle B above the x-axis, we are going to push it downwards, and then we shall have an angle B which will be, below the x-axis, and then they follow the same procedure. So if you're really interested, you can also check it out in the section, I think it was chapter 16 of the Pure Math book 1. So it shouldn't be hard for you to follow, but in the interest of time, we cannot really go through everything here. We shall just go through this, and then maybe the result will be easily, you can easily get it. So here we simply substitute now sine A, we simply substitute the result which we got above here. Okay, then this is cos A sine B, sorry, this is cos A, and this is sine B. Then we divide this by cos A plus B, okay, which is just here, which we got cos A cos B minus sine A sine B. Then you simply divide through, you know, everything in here. We divide through everything, numerator and the denominator. We are going to divide this through by cos A cos B. That is the trick. Cos A cos B, then we divide through everything here by cos A cos B. So you divide through everything. Okay, maybe let us do it very quickly here. So we divide through by cos A cos B. Okay, I'll make this large. And then we divide through by this cos A cos B, divide through by that, and then we also divide through this one here by cos A cos B. So sine divide by cos, of course. Okay, let us do this. Cos B will cancel with cos B, and then we remain with sine A over cos A, which is tan A. Then plus anything here which cancels, yes, cos A and the cos A cancel, and then you have sine B over cos B, which is tan B. Divide by, so here we have cos A and cos A, cos B and cos B, so we have 1, and then minus anything which cancels, no, but we can split it. Cos sine, sorry, divide by cos, which is going to be tan A, and then we have sine B over cos B, which is going to be tan B. Okay, and this is the result for tan A plus B. Okay, so the above we have derived simply called the additional formulae. Okay, they are the additional formulae. Now, to get our double angles, we shall just substitute in all these additional formulas. Okay, in these additional formulas, maybe I can also highlight this. Yeah, we should finish now, so as our video does not become so long. So in all these ones here which we have highlighted, maybe we call that one 1, and we call this one 2, and we call this one here 3. For the addition, for the double angle formula, we simply make the substitution. We make the substitution, and then we let A equal to B. Okay, so if we let A equal to B rather than having, so we have A. Okay, so we shall have that sine 2A equals to, of course, now this is going to be A and this is going to be A. Okay, so we shall have that this is going to be equal to sine A cos A plus cos A sine A, which should be equal to 2 sine A cos A. Okay, if I haven't made a mistake. Alright, that should be equal to 2 sine A cos A. And what about for the cosine here? If this is A, then we have that cos of 2A should be equal to, this is cos A, so this will be cos squared A, and then this is A. Remember, we're making the substitution, A equals to B, so this is sine squared A. Okay, and then lastly here for tan here, okay, we simply make the substitution. If A equals to B, so this we can make A, and then this we can make A. So we have tan A, oh sorry, not tan A, but this is tan A plus tan A, which is twice 2 tan A over 1 minus tan A, which is tan squared A. Okay, maybe we can complete here with another important result that comes from here. Okay, I'll just mention it, I won't go into detail. So cos squared, this one here, which says that cos 2A equal to cos squared A minus sine squared A, we can make the substitutions. Okay,